Hello everyone, this is a video for lesson 2.3a, modeling with quadratic functions, and you have one goal for this lesson. You're going to be able to write equations of quadratic functions using vertices, points, and x-intercepts. And I'm going to be a little bit more specific. You're going to use two forms. You're going to use vertex form and you'll use intercept form. So on your notes, we have three different forms of quadratic equations. They are not built equally. As you can see, each one has its pros and its cons. So vertex form, that one is very good for writing equations. We will be using that one today. We use that if you are given a vertex and a point, and that just makes sense because it's called vertex form. Vertex form is also good for transformations. It's really the only one good for that one. It's easy to find the vertex and the axis of symmetry and the y-intercept. The second one is intercept form. We have a little less practice with that one, so we'll get some more today. So intercept form is also easy to write an equation, but instead of being given the vertex, you will be given the x-intercepts and another point on the curve. It is not good for transformations, but it is very easy to find the vertex, the axis of symmetry, and the x-intercepts, but not the y-intercept. Standard form, that one we see a lot when you're solving or when you are trying to factor or graph. But it's not very easy to write an equation. It's not easy to tell what the transformations are. The easiest thing is to find the y-intercept because that's just the value for c. But we're not going to be using that one today. So I'm only going to do one example for each form in your notes today. There are a couple that you can try at the very end, but please let me know if you have any questions on this lesson. And I just want to mention very quickly that you should not be dependent upon Desmos, but you could, of course, just use a regular scientific calculator to make the calculations when you're writing your equation. The graph shows a parabolic path, which is known as a quadratic function, of the performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. The performer lands in a net 90 feet from the cannon. What is the height of the net? So the first thing we want to do is just take a second and look at this graph. Before we start writing our equation, we need to fully understand everything that the graph represents. So we have somebody that is being shot out of a human cannon. So they're actually going to get shot right here. This is where the cannon is. I can read this, that the cannon is 15 feet in the air. They're shooting the person up in the air, and this is the vertex. This is how high this person travels. Looks like 50 feet horizontally, but then they travel above the ground 35 feet. And then they land right here at the net, okay? So our ultimate goal is to figure out how high that net is. And for us to be able to do that, we need to be able to plug in 90 because I can tell, and the equation or the problem said that x was equal to 90. So what I need to be able to do is plug in 90 into our function to be able to figure out the y value, which is how high the net is. Before writing the equation, you need to think about two questions. What information do we know, and what form should I use? Well, since you know the vertex and another point on the graph, it makes sense for you to use vertex form. So this is how you write an equation in vertex form. Step 1, you're going to label your x and your y that comes from the additional point. H and K is from your vertex. So looking at the graph, I'm going to write down the vertex, which is 50 and 35. And the random point on the graph is 0 and 15. So that makes x equals 0, y equals 15. And then your vertex will have h is 50 and k is 35. Because h and k is special because it comes from your vertex. Step number 2, we're going to write down vertex form. So I'm going to change colors. Vertex form is y equals a times x minus h squared plus k. Then what we do is we substitute our x, y, h, and k. So I'm going to write everything I substitute in orange. So y is 15. I don't know a. X is 0. H is 50. And k is 35. After we substitute, we're going to simplify as much as we can. So I can go ahead and do 0 minus 50. Swap back to blue, which is negative 50. Then I'm going to square negative 50 using my calculator, and I get 2,500. And I'm going to write it in front of a because that's typically where we write the coefficient. And then I'm just going to scoot over here because I ran out of room. And then I'm going to continue solving for a. So I'm going to subtract 35. And I get negative 20. And then I'm going to divide by 2,500. You can leave this a fraction if you want to, as long as you're not, if you have to round it, then a fraction is better. But I don't have to round this. It is perfectly 0.008, negative 0.008. So I'm going to change it to a decimal. So one more time, if you're forced, if you divide it and you need to round, don't. Go ahead and just leave it a fraction. Now that I've found a, I can complete the last step. I'm going to write vertex form down one more time. And then I'm going to write in blue everything that I've substituted. So to finish the question, I need to substitute a, h, and k. So a is negative 0.008. H is 50. And K is 35. And that is your final form of your quadratic equation in vertex form. So now you can finally answer the question. It says, what is the height of the net? Now it already told us that the height of the net was 90 feet away. So what you're going to do is you're going to plug in 90 into your equation. Type that entire part into your calculator, everything that I've highlighted in yellow, and you wind up with 22.2. So what does that mean? So if you are 90 feet away, that means that you've landed in the net 22.2 feet in the air. And that's how high the net is. So the next example, you're going to be using the other form, which is called intercept form. So let's talk about why. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight, and y is the temperature in degrees Celsius. Write a function f that models the temperature over time. What is the coldest temperature? Well, before we can answer that question, we need to write a function. What are the two questions we need to ask ourselves? What information do we know? And what form should I use? So let's take a look at our graph. So as you see the graph, we're starting right here. So no hours have passed, and I'm starting at 9.6 degrees Fahrenheit. I'm sorry, Celsius. Let me do it right. Then it gives you the x-intercept right here. This is 0 degrees Celsius. That's where water freezes. then it dips below here, and then it comes back up to 0 degrees Celsius again at 24 hours after midnight. The question is asking us to find what is the coldest temperature. So where would the coldest temperature be? It would be in your minimum point. And your minimum point is down here. I can't really tell exactly where it is, but I need to find that minimum point. And the minimum point is the y value of that vertex. Now, you might be trying to find the vertex, but that's not the information given to you. You are given the x-intercepts and another point on the line. So, if you know your intercepts and a point, you're going to use intercept form to write your function. Okay, step 1 starts out very similar to the last example. We are going to write down the information that's given to us, our x-intercepts, and this is only the x value. That would be 4 and 24. And the other point on the graph was 0 and 9.6. So we need to label our x, y, p, and q. With your intercept form, it does not matter which one that you label p or q as long as those two are your intercepts. So we're going to use 4 and 24 for those. And this has to be your x and that has to be your y. So 0 and 9.6. Now that we have that written down, we're going to write intercept form, our generic form, which is y equals a times x minus p times x minus q. And you're going to plug in everything but a. So y is 9.6, x is 0, we said p is 4, and then x is 9.6 minus, x is 0 minus 24. Then we're going to simplify as much as we can. So you can do 0 minus 4 and 0 minus 24. You can go ahead and multiply those two numbers together and we get 96. And you know what? I'm going to put that in front of a because that's where we put our coefficient. I'm going to divide by 96. And then we wind up with a is equal to 0.1. Once again, if you're forced to round a decimal, it's better for you to change it to a fraction instead. Never round when writing a function. Okay, last part, we are going to write down our intercept form again. And the only parts that you need to substitute are your a, p, and q. Now, if you wind up with minus a negative, make sure that you simplify that to plus a positive. Okay, that is our final answer in intercept form. And then we can finally answer the question, what is the coldest temperature? Well, we determined by looking at our graph that we need to find the vertex to help us find our answer. Since this is intercept form, the way that you find your vertex is you start with the axis of symmetry. And your axis of symmetry is the average of your two intercepts. So my intercept is 4 and 24. So the average, or the line that goes right down through the middle of those, would be 14. So your axis of symmetry is 14. Let's go up to your graph and we're going to draw that. So I'm going to put a line right here where I feel like it's x equals 14. Should be about right here. Now that is going to also match the first part of our vertex. We've practiced that before. So we're going to plug in f of 14 into our function. And then we are going to type all of this part into our calculator. And we wind up with -10. So if our vertex goes all the way down to -10, that is our minimum value. And let's write our answer in context. So the coldest temperature was -10 degrees Celsius. Now that I've done 2 examples for you, now's the time for you to just kind of pause the video, and I need you to read these 2 questions, and you need to determine which form you should use for each, and then go ahead and follow steps 1, 2, and 3, and let's see if you get the answer right. All right, so let's talk about the first example. So I chose to use vertex form because it told me the vertex and I would need to substitute h and k. So I labeled all of my points x, y, h, and k. I wrote down vertex form and I plugged it in. You can see what I plugged in orange. Then I simplified 1 minus -2, that's 3. 3 squared is 9, so I wrote 9a. Subtract 5 from both sides, you get -12, divide by 9. Now if you type in your calculator -12 divided by 9, you get a repeating decimal. You cannot write a repeating decimal, you're forced to round it. Never round when writing a function, so we're going to leave it as an improper fraction. So to finish the question, we are going to substitute -4/3 for a, -2 for h, +5 for k, and then simplify just a little bit. I mentioned before, if you have minus a negative, change that to plus a positive. And that's your final answer. Okay, let's look at our last example. I determined that we needed to use intercept form because it gave us the intercepts instead of the vertex. So I went ahead and I labeled x and y, p and q. I wrote down intercept form and I substituted x, y, p, and q. I simplified these 2 parentheses to 4 and -2, multiplied them together, I got -8, divide both sides by -8. I decided to leave it a fraction. You can change it to a decimal. You can change it to 0.625. As long as you're not rounding, that is acceptable. A lot of times they do leave it as fraction forms because it's just easier to write your standardized tests that way. So just be aware of that. Once you figured out a, you can go back in and substitute a and then your 2 x-intercepts. And then I just kind of cleaned it up a little bit. Instead of minus -2, I changed it back to x plus 2, and that's our final form. And you have a handful of questions. You've got 6 of each type that you need to practice. And as always, just let me know if you have any questions.